Okay, this is part 3 of section 4B, looking at the power of compounding. We've been talking about compound interest. We just talked about compounding continuously. And in this question, we are going to try to determine how much we must deposit in an account today in order to have a $120,000 college fund 15 years from now. And we assume that no additional deposits are made. And we're going to look at an APR of 2.85% compounded quarterly, and we're also going to compare that to compounded continuously. So we know that our end result is $120,000. That's what we want. We do not know the principal or the starting amount. We know the rate is 2.85%, and this first one is compounded quarterly, so 4 times a year. And again, we are over 15 years. That's using the compound interest formula. And so to solve for P, we're going to divide by both sides by this big monstrosity here so that we can isolate our variable P. So 0.0285 over 4 to the 4 times 15 power. Because again, those will cancel out. And eventually here you'll get that the principal, or the amount you should invest today, would be $78,375.20. Okay, that would be the amount you need to be investing today to have $120,000 in 15 years compounded quarterly. Okay, so again, this is when we're compounding quarterly. Now what happens when we switch over and we go continuously? So continuously, we want $120,000, so the amount equals the principal times E, Euler's number, again, approximately 2.71, raised to the 0.0285 times 15 power. Okay, now again, remember E is just a number, 2.71, and it's an irrational number, so decimal never ends, never repeats, but that's what E is. You can type in your calculator. So we're going to divide both sides by e to the 0.0285 times 15 power. To cancel those out, so that when I type in 120,000 divided by e to the 0.0285 times 15 power, I'm going to get that the principal here is about $78,256.49. So not a tremendous difference when we're compounding continuously, but we would need to invest about $119-ish less if we're compounding continuously in order to get that same goal. So compounding continuously is going to give you more yield in your interest over time, but it's not as drastic as some people think that it does turn out to be. But that's a comparison of the two when you're looking for a goal of $120,000. So the next thing we're going to look at to end here is what we call the annual percentage yield, or APY. Sometimes you'll see this called the effective yield, or sometimes just the yield. Okay, and this is the actual percentage by which the balance increases in 1 year. So if you are compounding annually, then it is just your APR. However, it is greater than your APR if you're compounding more than once per year. And this is a good way, the APY is a good way to compare two accounts. If one has an APR of a certain percentage compounding quarterly, and the other has a different APR but compounding annually, you can compare the two using this annual percentage yield to see which one is actually the better or going to give more money in the end. So when we're looking at APY, okay, what APY is going to do, the way we calculate this, is we're basically just going to peel off the present value, or the principal, P, and we're just going to assume we're investing $1, essentially is what we're going to be doing here, but we take the portion that is 1 plus the APR over the number of times compounded, raised to the n, and we're only looking at a single year, because again, this is annual percentage year. So we take this portion, and hopefully again you can see where that is built into the compound interest formula. So we take this, and that's going to give us some number, and then we need to subtract 1 because the first part is going to give us kind of a percentage that we have grown, and then we need to subtract off 1, which is subtracting off 100%, because if it's growing at, say it's growing at 4%, then this part's going to give us 104%. So we subtract off 1, which is 100%, to see that we have a 4% yield over that year. So that's where those are coming from. That's why there's a subtract 1. If you're compounding continuously, so I should put this is for continuously, then again, you'll see this, you can see this embedded in the formula, but you just take e raised to the APR power and then subtract 1 for it for the very same reasons. So P we assume is 1, just as if we're investing $1 to make it as simple as we can. And then years is always 1 because we're looking at an annual percent yield or yield over 1 year. Okay, so we want to find the annual percent yield if a bank offers an APR of 4.1% compounded daily. So we have N as 365. APR is going to be 0.041. So the APY here is going to be 1 plus 0.041 over compounding daily 365 raised to the 365 power, and then subtract 1 from all of that. When you do that, again, please make sure you're able to get these numbers in a calculator. We get approximately 0.0418, which as a percentage is 4.18%. So you can see that even though our APR is 4.1%, when we're compounding daily, we're actually getting a yield of 4.18%. So we went from 4.1 to 4.18. Because of that compounding daily, we see a little bit more in the end. Sometimes people refer to the APY as, how much simple interest are you really getting in that account over a year, and that's another way to look at it. Okay, this next one we have, this as a practice again, we have a bank offers an APR of 2.25% compounded quarterly. We want to find the APY, so we're going to have APY is equal to 1 plus 0.0225 over quarterly. There are 4 quarters in a year. Raised to the 4th minus 1. So this is, we get approximately 0.0227 or 2.27%. So again, we can see here that compounded quarterly, that our APY is a little bit bigger than our APR. Again, because of that compounding quarterly. Now, I said later in the lesson we were going to come back to number 75, and here we are, because we are going to find the APY when we are compounded continuously. So the APY in this question is going to be equal to E raised to the power of, since it was 4.5%, 0.045, and then subtract 1 from that, and you will get 0.046 or 4.6%. So again, notice that compounding continuously, we actually get a 4.6% annual yield when we started out at 4.5% for our yearly. So again, that's how this compounding will affect those yields. And again, APY is a very effective way to compare and contrast 2 different loans. If you have, one scenario says APR of this percent compounded this long, and another one gives you a different APR but compounded this long, you're able to use the APY to compare the 2, kind of bring them down to the same level and find out, how much am I exactly going to get per year in my yield, my effective yield. And so that's one of the very helpful places of APY. So that concludes section Unit 4B. And if you have any questions, please don't hesitate to let me know, and I appreciate your time in watching this video.